From the moment we wake, a ritual begins. A simple act, repeated billions of times across the globe, yet few ever pause to consider the hidden world behind it. We reach for a tube, squeeze, and brush, oblivious to the intricate journey, the scientific marvel, and the unexpected origins of the paste that cleanses and protects. What if I told you that within that everyday tube lies a secret, a testament to industrial ingenuity that transforms the most unlikely of raw materials into a cornerstone of modern hygiene? This isn't just about cleaning teeth. It's about a profound connection between ancient biological structures and cutting-edge chemistry, a story of transformation that begins far from the bathroom sink. Imagine stepping through a portal, beyond the supermarket aisle, past the glossy advertisements, and into the beating heart of creation itself. This isn't just a factory. It's a crucible where science meets industry, where ancient elements are reborn with a purpose. We are about to pull back the curtain on a process so precise, so transformative, it borders on alchemy. Forget what you think you know about manufacturing. This is a journey into the unseen, a deep dive into the sophisticated machinery and the meticulous chemistry that crafts the very substance we trust with our oral health. The air here is thick with the promise of discovery, a subtle hum of machinery that orchestrates a complex dance of purification and synthesis. The air hums with controlled power, a symphony of automation and human expertise. Here, the ordinary becomes extraordinary, and the seemingly impossible becomes routine. You're not just observing, you're becoming an insider, privy to the secrets of a global industry. We will explore the surprising origins of a key ingredient, tracing its path from a raw, organic state to a refined, essential component. This is the story of how a fundamental building block of life, often discarded, is meticulously processed and purified, not just for survival, but for the enhancement of daily life. It's a narrative that speaks to the incredible resourcefulness of modern industry, finding value and utility in what was once considered waste, elevating it to a high-grade, indispensable material. Prepare to uncover the hidden world behind everyday products, to witness the transformation of raw materials into the polished, functional items that define our modern existence. This is a narrative of precision, of scale, and of the relentless pursuit of perfection. It's a story that will change the way you look at your morning routine forever, revealing the profound industrial mystery concealed within a simple tube of toothpaste. The sheer scale of the operation, the scientific rigor applied at every stage, and the unexpected source of its core components will leave you with a newfound appreciation for this humble yet complex product. The history of oral hygiene is far more ancient and fascinating than most realize, stretching back millennia before the advent of the modern toothpaste tube. Early civilizations, from the Egyptians to the Romans, understood the importance of clean teeth, though their methods were rudimentary by today's standards. Imagine chewing on twigs, rubbing abrasive powders made from crushed eggshells, ox hooves, or even charcoal onto your teeth. These were the precursors, the earliest attempts to achieve what we now take for granted. The concept of a tooth powder or dentifrice has existed for thousands of years, evolving slowly from simple abrasives to more complex formulations. The ancient Egyptians, for instance, used a mixture of rock salt, mint, dried iris flower, and pepper to create a tooth powder as early as 5000 BC. The Romans favored ingredients like urine, believed to whiten teeth due to its ammonia content, alongside more conventional abrasives. These early efforts, while crude, laid the groundwork for the scientific advancements that would follow. But the leap from these ancient concoctions to the sophisticated pastes of today is a story of scientific discovery and industrial innovation. For centuries, the primary goal was simply cleaning, removing food particles and surface stains. The idea of actively protecting teeth, strengthening enamel, and fighting decay came much later. It wasn't until the 19th century that tooth powders began to incorporate ingredients like soap or chalk, and the first true toothpaste in a jar emerged. The real game changer, however, was the invention of the collapsible tube in the late 1800s, transforming toothpaste from a luxury item into an accessible daily essential. This seemingly minor packaging innovation democratized oral hygiene, making it convenient and hygienic for the masses, a pivotal moment in public health history. One of the most mind-blowing details about modern toothpaste often overlooked, is the incredible journey of its abrasive component. While many contemporary toothpastes use silica or other synthetic abrasives, a significant portion, particularly those focused on enamel strengthening and repair, still rely on a derivative of calcium phosphate. And where does a highly pure, bioavailable form of calcium phosphate often originate? From an unexpected source: animal bones. This might sound startling, but it's a testament to the circularity of industrial processes and the ingenuity of chemists. The processing of bones, primarily from cattle or pigs, into a refined, pharmaceutical-grade calcium phosphate is a marvel of chemical engineering. It's a far cry from the crude bone ash of ancient times, representing a sophisticated valorization of a biological byproduct. Consider the sheer scale of this operation. Billions of tubes of toothpaste are produced annually. Each tube requires a precise blend of ingredients, and for those utilizing bone-derived calcium phosphate, the demand for this highly refined material is immense. The journey begins in slaughterhouses, where bones, often considered a byproduct, are collected and meticulously cleaned. This isn't a simple grinding process. It's a multi-stage chemical and physical transformation designed to extract the purest form of calcium phosphate, free from organic impurities. The initial steps involve degreasing and demineralization, often using hot water and chemical baths to remove fats, proteins, and other organic matter. The goal is to isolate the inorganic mineral matrix, a process that requires strict control to avoid degradation of the desired mineral. Once cleaned, the bones undergo a calcination process. Essentially, they are heated to extremely high temperatures, often exceeding 1000 degrees Celsius, in specialized kilns. This intense heat burns off any remaining organic material, leaving behind a brittle, porous white ash primarily composed of calcium phosphate. This ash, while rich in the desired mineral, is still far from the fine, pure powder needed for toothpaste. It must then be ground into an ultrafine powder, often through a series of ball mills or jet mills, until the particle size is precisely controlled. This particle size is critical. Too coarse, and it's too abrasive for enamel. Too fine, and it loses its cleaning efficacy. The uniformity of particle size is also crucial for the toothpaste's texture and stability, preventing grittiness or sedimentation. The purification doesn't stop there. The calcium phosphate powder often undergoes further chemical treatments, such as acid washing and precipitation, to achieve the desired purity and crystalline structure. For instance, dicalcium phosphate dihydrate, DCPD, or tricalcium phosphate, TCP, are common forms used, each with specific abrasive and remineralizing properties. The exact form and purity are crucial for the toothpaste performance, ensuring it effectively cleans without damaging enamel, and in some cases, actively contributes to its repair. This meticulous refinement ensures that what started as a raw, organic material is transformed into a safe, effective, and highly controlled ingredient, meeting the stringent standards of pharmaceutical and cosmetic industries. Did you know that the very first commercially produced toothpaste in a tube, Dr. Washington Sheffield's creme dentifrice, was introduced in 1892? Before that, people bought tooth powder in jars or tins and applied it with a wet brush. The convenience of the tube revolutionized oral hygiene, making it a truly mass-market product. This seemingly simple innovation had a profound impact on public health, making daily brushing more accessible and hygienic. It also reduced contamination risks associated with dipping brushes into shared jars, marking a significant step forward in personal hygiene. The evolution of toothpaste ingredients is equally fascinating. Early formulations often contained ingredients that would shock us today, like soap, chalk, or even sugar, before its detrimental effects on teeth were understood. The inclusion of fluoride in the mid-20th century marked another monumental shift, dramatically reducing the incidence of dental cavities worldwide. This single ingredient, initially met with skepticism, became a cornerstone of modern preventive dentistry, showcasing how scientific understanding can transform public health on a global scale. The widespread adoption of fluoridated toothpaste is credited with a significant decline in tooth decay rates, especially in developed countries, saving countless individuals from pain and expensive dental procedures. modern innovations continue to push the boundaries. Beyond fluoride and abrasives, today's toothpastes incorporate a dizzying array of active ingredients, desensitizing agents for sensitive teeth, whitening compounds, antibacterial agents, breath fresheners, and even ingredients designed to rebuild enamel at a molecular level. The science behind these formulations is incredibly complex, involving a delicate balance of pH, solubility, and bioavailability to ensure each ingredient performs its function effectively without interfering with others. It's a testament to continuous research and development in the field of oral care, driven by consumer demand for specialized solutions and ever-improving scientific understanding of oral health. Consider the engineering challenges involved in creating a toothpaste that remains stable on the shelf for years, yet flows easily from the tube, has a pleasant taste and texture, and delivers its active ingredients effectively. This requires a deep understanding of rheology, the study of how matter flows, and colloid chemistry. The precise blend of humectants, like glycerin or sorbitol to prevent drying, binders, like cellulose gum to prevent separation, foaming agents, like sodium lauryl sulfate, and flavorings must all work in harmony. It's a chemical ballet performed in every tube, where the slightest imbalance can lead to a product that separates, hardens, or simply doesn't feel right in the mouth. Achieving this perfect balance is a significant feat of formulation science. And what about the environmental impact? The sourcing and processing of raw materials, including bone-derived calcium phosphate, are subject to increasingly stringent environmental regulations. Factories are constantly innovating to reduce water usage, minimize waste, and improve energy efficiency. The byproduct bones, which might otherwise be discarded, are given a new life, contributing to a more sustainable industrial ecosystem. This focus on sustainability is a modern imperative, driving changes across the entire manufacturing chain, from responsible sourcing to eco-friendly packaging. Many companies are now exploring plant-based alternatives for certain ingredients and developing recyclable or biodegradable packaging solutions to further reduce their ecological footprint. The global relevance of toothpaste is undeniable. It's a product found in virtually every household, transcending cultural and economic boundaries. The market is vast and competitive, with manufacturers constantly striving for new formulations, better efficacy, and more appealing sensory experiences. From the bustling metropolises to the most remote villages, the simple act of brushing teeth with toothpaste is a universal habit, a small but significant part of daily self-care that contributes to overall health and well-being. It's a record-breaking industry in terms of sheer volume and global penetration, a true testament to its essential role in modern life. The continuous innovation in flavors, textures, and specialized benefits ensures that toothpaste remains a dynamic and indispensable product in the global consumer market. The journey of transforming raw materials into a finished tube of toothpaste is a meticulously orchestrated industrial ballet, beginning long before the ingredients ever reach the factory floor. For a toothpaste utilizing bone-derived calcium phosphate, the process starts with the careful selection and pre-processing of bones. These are typically sourced from certified slaughterhouses, ensuring traceability and adherence to strict health and safety standards. Upon arrival at specialized processing facilities, the bones undergo rigorous cleaning and degreasing to remove all organic matter, including fats and proteins. This often involves high-pressure washing, chemical baths, and enzymatic treatments. The goal is to isolate the inorganic mineral matrix, ensuring the final product is free from any undesirable biological contaminants. Once cleaned, the bones are subjected to calcination. This critical step involves heating them in massive rotary kilns to temperatures exceeding 1000 degrees Celsius. This intense heat incinerates any remaining organic impurities, leaving behind a brittle, porous material primarily composed of calcium phosphate. The resulting calcined bone, often referred to as bone ash, is then cooled and transported to the toothpaste manufacturing facility, or more commonly, to a specialized chemical plant for further purification into a pharmaceutical-grade calcium phosphate powder. This intermediate processing ensures that the calcium phosphate delivered to the toothpaste factory is already of a high standard, ready for final formulation. Upon arrival at the high-tech toothpaste factory, all raw materials, including the purified calcium phosphate, fluoride compounds, humectants, binders, flavorings, and water undergo stringent quality control checks. Each batch is sampled and tested for purity, concentration, particle size, and microbial contamination. Only materials meeting the exact specifications are cleared for production. This initial vetting is paramount to ensuring the safety and efficacy of the final product, preventing costly errors and potential health risks down the line. Advanced analytical techniques, such as chromatography and spectroscopy, are employed to verify the chemical composition and absence of impurities. The manufacturing sequence begins in large, stainless steel mixing tanks, often several stories high. These tanks are equipped with powerful agitators and precise temperature control systems. The first step typically involves preparing the liquid phase. Purified water, which has undergone reverse osmosis and deionization to remove all minerals and contaminants, is pumped into the tanks. Humectants like glycerin or sorbitol are added next. These ingredients are crucial for preventing the toothpaste from drying out and for giving it its characteristic smooth texture. High-speed agitators ensure thorough dissolution and homogeneity, creating a clear, viscous solution. Next, the binding agents, such as cellulose gum or carrageenan, are introduced. These hydrocolloids are responsible for giving toothpaste its consistent body and preventing the separation of solid and liquid components over time. Their dispersion requires precise control of temperature and mixing speed to avoid lumps and ensure a smooth, stable gel base. This stage is critical for the toothpaste's rheological properties, how it flows and holds its shape, and directly impacts the user's experience. The binders also help suspend the abrasive particles evenly throughout the paste. Once the base gel is formed, the abrasive components, including the highly refined calcium phosphate, are carefully added. These powders are typically pre-sieved to ensure uniform particle size and are introduced slowly to prevent clumping. The mixing continues, often under vacuum, to prevent air bubbles from becoming entrapped in the paste, which could affect its texture, stability, and even its volume. The abrasives are essential for physically removing plaque and stains from tooth surfaces, and their precise concentration and particle morphology are carefully controlled to ensure effective cleaning without causing enamel abrasion. Following the abrasives, the active pharmaceutical ingredients, ARPAs, are incorporated. This most commonly includes fluoride compounds, such as sodium fluoride or sodium monofluorophosphate, which are vital for strengthening enamel and preventing cavities. Other ARPAs, like potassium nitrate for sensitivity or zinc citrate for antibacterial action, would also be added at this stage. Precision dosing is achieved through automated gravimetric or volumetric feeders, ensuring the exact concentration required for efficacy and safety, in compliance with regulatory standards. The order of addition is often critical to prevent unwanted reactions between ingredients. Finally, the sensory components are introduced. Flavorings, like mint oils, often encapsulated for sustained release, non-caloric sweeteners, and foaming agents, like sodium lauryl sulfate. These ingredients contribute significantly to the user experience, making the toothpaste palatable and pleasant to use, encouraging regular brushing. The mixing continues until a perfectly homogeneous paste is achieved, a process that can take several hours depending on the batch size and formulation. This final blend is then subjected to another round of rigorous quality control tests, including taste, texture, pH, viscosity, and microbial load. Throughout the entire mixing process, advanced sensors continuously monitor parameters such as temperature, pH, viscosity, and homogeneity. Automated systems adjust mixing speeds and ingredient additions in real time, minimizing human error and ensuring consistency across batches. Data from these sensors is logged and analyzed, providing a complete audit trail for every batch produced. This level of automation and data collection is a hallmark of modern, high-tech manufacturing. Once the toothpaste is fully mixed and approved by in-process quality control, it is transferred via sealed pipelines to the filling and packaging lines. These lines are highly automated, utilizing robotics and sophisticated conveyor systems capable of processing thousands of tubes per hour. Empty tubes, typically made of laminated plastic or aluminum, are fed into machines that precisely fill them with the correct amount of toothpaste. Optical sensors verify fill levels, and induction sealing technology creates an airtight seal at the tube's opening, preserving freshness and preventing tampering. After filling, the tubes are capped, often by robotic arms, and then moved along a conveyor to the cartoning machines. Here, each tube is inserted into its individual cardboard box, along with any accompanying leaflets, e.g., instructions for use, ingredient lists. Further automated systems bundle these cartons into larger display boxes or shipping crates, ready for distribution. Throughout the packaging process, multiple layers of quality control are in place. Vision systems inspect each tube for defects, correct labeling, and proper sealing. Weight checks ensure consistent product quantity. Metal detectors scan for any foreign objects. Any product failing these checks is automatically rejected from the line, often with an automated system for root cause analysis. Finally, the finished products are palletized by robotic arms, shrink-wrapped for protection during transit, and prepared for logistics. The entire factory environment is maintained under strict hygienic conditions, with controlled temperature and humidity, and often positive air pressure to prevent contamination. Employee safety is paramount, with extensive training, personal protective equipment, and automated safety interlocks on all machinery. From raw material reception to the final palletization, every step is a testament to precision engineering, advanced automation, and an unwavering commitment to quality and safety, ensuring that every tube of toothpaste meets the highest standards before it reaches your home. And there you have it, the incredible, often unseen, journey from raw materials to the very toothpaste you use every day. Who would have thought that behind such a common product lies a world of ancient history, cutting-edge science, and the surprising transformation of something as fundamental as bone into a vital component of our oral health? It's a testament to human ingenuity and the relentless pursuit of improvement, turning what might be considered waste into a highly valuable and essential ingredient. This deep dive into the high-tech toothpaste factory is just one glimpse into the hidden industrial wonders that shape our world. If you are fascinated by the meticulous process of transforming raw materials into a refined product, imagine the intricate dance of machinery and nature required to turn towering trees into the lumber that builds our homes and furnishes our lives. The precision, the scale, and the sheer power involved in shaping raw timber into usable materials are equally astounding. Don't miss our next adventure. A new video just appeared on your screen, taking you inside a high-tech lumber mill, where massive logs are precisely transformed into usable timber, revealing the astonishing technology and surprising challenges of this ancient industry. From debarking to precision cutting, grading, and drying, you'll witness every step of how a forest giant becomes the backbone of construction. Click on it now to continue your journey into the heart of modern manufacturing. And if you enjoyed uncovering the secrets of the toothpaste factory, make sure to subscribe to our channel for more exclusive behind-the-scenes access to the world's most incredible industrial processes. Hit that subscribe button and ring the notification bell so you never miss an episode. Join our community of curious minds eager to explore the hidden mechanics of our daily lives. What was the most surprising fact you learned about toothpaste today? Was it the ancient origins, the unexpected raw materials, or the sheer precision of the manufacturing process? Perhaps the intricate balance of ingredients or the rigorous quality control? Let us know in the comments below. We love hearing your thoughts and discoveries. Your insights fuel our next explorations.